Hi everyone. I'm going to be telling you about CoRet, the improved code retriever for code editing. My name is Fabio. This work was done during my PhD at EPFL in India and during an internship at Amazon in Berlin. So imagine yourself as a new developer coming to a team, and they give you this pile of code, a large unidentified repository, and they give you a natural language statement saying you need to fix this bug of XYZ and implement something. So then you take this code and you sit down at your computer and you think, okay, how do I fix this bug and implement this? Well, the first thing you should think is, well, which parts of the code should I look at to do the editing or retrieve? So this is what we frame as the code editing retrieval problem. So in this talk, we're going to be telling you a bit about how to train a lightweight code retriever. That includes the semantics and understanding of the code, as well as the structural repository level and interconnectedness of the repository as well. So let's have a look at the code. So we get given a code repo here with some imports, definitions, classes, etc. And then we do some pre-processing. And this pre-processing first chunks the code. It puts it into meaningful, succinct units that, as you can see here, are the classes or the methodologies or the methods, not methodologies, or the functions as well. And then we augment them with the repository hierarchy or the file paths, which we'll see is an important feature later. Next, before we pass this into our model, we take the function or the piece of code, the chunk, and its outgoing call graph neighbor. And we concatenate that together with a special token. And we also use kind of a positional token so that this can be disambiguated, like BERT uses. And then we pass that to our lightweight retriever, CoRet. And this is how it gets kind of a call graph context. And the model is built on a code sage small, which is only 130 million parameters. Then to align the code and the natural language query question for retrieval, we need to do some fine tuning. And the first thing we do is we take the loss function here and we take the n here is the number of different repositories we're going to be using. C star here is the ground truth chunks. And then we do a form of likelihood or contrastive loss. This is the same formulation where we take kind of the similarity between our query and the ground truth chunk we want to retrieve, except we normalize by not the in-batch negatives, which is what's used in contrastive learning. We normalize by other chunks with inside the same repo. So that's what B is here. So then for the data that we use is we use SweBench and the verified subset, which is a software engineering benchmark. And then we use the long code arena benchmark or task, which is for bug localization. And finally, we have a small lightweight model, which we found to be the best, which was code sage small. So then if we look at whether the repo hierarchy is being used or effective, we did some ablations in the paper, but we can see here in the attention patterns that this is clearly being used, this kind of path-like information. Next, if we look at the call graph, we find that it actually makes the biggest improvements when you have lots of multi-chunk retrieval to be done. So this in the long code arena has many multi-chunk options, and we see the biggest performance boosts here. Then finally, our loss function, we evaluate that, and we compare it to the in-batch or the contrastive learning approaches, which are these kind of blue and purple options. And when we use the batch, the negatives that come from inside the sample, we actually get negatives that come from inside the repo itself, we actually get the biggest performance boost. So it's steering us towards using this likelihood approach. And finally, we get kind of overall an improvement of about 15 percentage points on SweBench verified, which was pretty good. And yeah, so this was how to train a lightweight code retriever with semantics and structure. and hopefully to see you at Vienna and come check out our poster.